Hello, everyone. It's Keith LaRose here at Coppertree. So we're just about to get started on today's webinar. I'm going to give folks a couple of minutes here to stream in, literally. And once we have a couple more folks join, we will get started. And looking forward to today's presentation. I'll be with you back in about 3 minutes time to get things kicked off. Okay, everyone. Thank you again for joining. We're going to get started on today's program. As a reminder, this session is being recorded, so the recording will be made available to all attendees and anyone who couldn't make it as well. So we look forward to, if you couldn't make it, look for the registration for the email coming to the email address you registered with. And for those of you there's going to be quite a bit of discussion here today, but for you who would like some more maybe in-depth technical information, we're going to go to a certain level. We'd be happy to engage on a separate session, of course, with you at any time. So here we go. So streamlining operations, a deep dive into Coppertree's Kaizen, ACX, and ASO. Just a bit of background, I suppose, about Coppertree. Some of you are very familiar with us, seeing some of the names that are on the attendee list. However, we may be new to some folks. So Coppertree was founded in 2012. We're the designer and the makers of a software family called Kaizen, which we're adding new applications to continuously. And today's discussion will be around a couple of the newest class of tools that we have added to the stable, so to speak. We're deployed to over 3,000 buildings worldwide, probably more than that over the history of the company, of course. And every day we've kind of lost track maybe of how many points, but it's over 1.3 billion data samples that we're pulling into our servers each day. And it represents hundreds of millions of square feet of building stock around the world on 6 continents. So we've been at this for a little while. I myself have been at Coppertree since 2012 as well. 2013, I guess, sorry. So just over, coming up on 12 years here. And, obviously tremendous amount of change and technological evolution in our industry since that time. So happy to be here today to talk to you about some of that. Most recently on our corporate journey, we have been acquired at Coppertree in 2023 by a group of companies formerly known as DAR Group, but going by Sedara now. There are 20 companies in our group, some of which you may be familiar with in your professional life, including Perkins and Will Architects, Introba Engineering, TY Lin, Curry and Brown. Altogether, I believe we're ENR ranked number 9 in consultancy and advisory and engineering companies worldwide. So a big presence worldwide. We fit quite well into this group, being a digital first company. We're helping to evolve some of the processes and the strategies that have been undertaken in our design, engineering, commissioning, and other parts of the industry. So really good fit there. Obviously, expertise in buildings and the built environment is core to the group. So Coppertree typically find ourselves deployed into kind of 3 main buckets of clients. More and more, obviously, we're doing new construction. ACX, or automated commissioning and functional testing, definitely fits into the new construction bucket, and we'll be speaking about that and how that helps with that phase of a building's life cycle. So new construction, coming through, making sure that deficiencies are identified and minimized, and closing the performance gap between the design and what's actually delivered to facilities operations at the other end of the construction project. So there's a lot there about quality control, assurance that what is designed is being delivered, so that we're starting the operation of the building with as little deficit in performance as possible. So the new construction piece we'll speak about a lot with the ACX portion of our agenda today. The next thing that we do quite a bit is a retrofit application. So that is going into existing buildings, applying the technology, being able to help with optimization of the performance of the building. So both for energy, more and more now for maintenance measures as well, which we'll talk about in the next bucket. But retrofit, typically we're associated there with decarbonization, retro commissioning, continuous optimization. And the automated system optimization piece has a lot to do here with retrofit, as well as the FDD tool. And finally, building operations. More and more now, we are being relied upon as a transformative technology to help shift people's maintenance procedures away from reactive or traditional maintenance towards not only predictive, but also automated maintenance procedures. And we'll talk about that with ACX and how that can be leveraged in order to replace quite a bit of the preventive maintenance that might be taking place currently using human inspection and testing on an ongoing basis. So carrying on, that's kind of the 3 main buckets you might find us. And so the why of building analytics, especially as it relates to ACX and ASO, which is really why we're here today, is that these technologies help with the fact that the systems are quite complex to design, more and more complex as well. So of course, with higher requirements from code, electrification, more energy recovery, there's passive design, there's a lot of geothermal that we're seeing, there's a lot of very efficient sequences being designed into these buildings. They become more and more complex to program, to commission, and then of course to operate over time. So the more complexity gets added within the design, of course, the more complexity flows through all of those processes out to the other end. And still, even though it's 2025, we find data being difficult in the traditional sense. If you just were given a normal building, the run-of-the-mill building that we see many of, data extraction from those systems that are within the building can be troublesome, if not near impossible, and there's a lot of siloed data still that we're seeing. So we'll talk a little bit about that. And the fact is that time-based preventive maintenance has been around far too long for some of these systems. There is data available for them. We can transform how that preventive maintenance is taking place using technology. So what we save there, we can apply that labor and that effort and those resources, including dollars, elsewhere to improve the performance of the building and achieve other goals that we might have. So that's the overarching why. Just to talk a little bit about data sources, abstraction, the overall picture of where the data is coming to from and going to, I should say. There initially is a data source, right? So that data source traditionally, when we first started this journey, was typically building automation system We would have interval meters sometimes, once in a while utility bills. Weather data started being added more and more as we did more energy work, in the early years. But more and more, we're getting IoT sensors, third-party, solutions being integrated, such as IAQ sensors or occupancy detection systems that may or may not be integrated to the building automation system. So thinking about that, it's really interesting to think about the expansion of the scope of the data that is being collected and is useful for that. Getting at that data and making it useful and collecting it and storing it previously had been a little bit more difficult, I would say, because there was less focus on generating or keeping APIs for each individual system. Depending on the integration done at site, that data might all be integrated into the building automation or into its own independent layer. So we're seeing that more as well. Where that doesn't exist, Coppertree creates that layer. So if there isn't an independent data layer, in which case there is sometimes, we now are collecting all of that data through either server integrations, including SCADA and other types of integrations, through APIs, through file and CSV integrations even. I mean, we still have people emailing us CSV files, believe it or not, and we parse those and take the data and push them into the cloud layer in order to store those next to the data that we are collecting through BACnet, Tritium, and other drivers. We've got about 130 or so of these connectors now that we've developed and have in our repository. Those connectors are harnessing that data and pushing it into a cloud layer. And sometimes that's all customers want. They'll actually follow this string through. We have it in the cloud layer, follow this down here, and we push it out either raw or processed, however we want. But that goes into our API, and that API is available to third-party applications such as digital twins, CMMSs, unified user interfaces, or anything else the customer might be using in their body of work. So that is one sort of use case that we're seeing more and more of is the use of our data engine and the independent data layer, essentially, is what that would call it. So in the independent data layer, there is the ability to create context around that data. So we can contextualize the data and provide it structured to the client in whatever system they'd like through the API. But traditionally, we're known as well for the applications that we host on top of these data. So we have an energy information system, fault detection and diagnostics, and the two main topics we're going to be talking about today, which is automated system optimization and automated commissioning and testing. So, and again, API first, we've definitely embraced that, as have most vendors in the industry, so that we can mix and match. So if a customer has a cloud layer already, we can just start here, grab that data through an API and apply whatever of these application layers that we want to do. Or, again, if the client only just wants data out, then they just pull that data out through the APIs. I think it's important to understand the fundamentals. So historically, this would be our functional solution diagram as far as the data flow goes. So we would have the data collection at site, let's say, from the building management system, building automation system, any sensors that are integrated there, meters, et cetera, plus and or integrations through APIs. So if there was a data layer that we're pulling from, we would be pulling that from the API down here. That data is all transmitted and stored within Kaizen, the analytics servers, where we apply algorithms and we host the user interface. So historically, that is a read and pull mechanism. So we're reading data from both the API and local site systems and pushing that data and mixing it all in with weather and other information we're pulling in and applying our algorithms to that data. So historically, that was always an outbound only, one direction data flow. And that enables both the EIS, which we're not going to really talk about today because it doesn't feature too much into the ASO and ACX picture, but we will start with fault detection and diagnostics as a quick refresher for those who may not be familiar, because it does form the base of what we do with ASO and ACX. Complementary, not necessarily required, but definitely complementary, and the same underlying technology for both of them is used. So fault detection diagnostics, as a quick primer, it's a software-driven approach. It automates the analysis of multi-data sets. So you have the data coming from the building mixed with other data, as I mentioned, and to be able to run algorithms, both rule-based, but also pattern recognition, some modeling on those, et cetera. So the ability to parse, contextualize and analyze that data. The goal for that really is pinpointing faults in very complex systems. So being able to do vast analysis across hundreds or thousands of systems at once and pinpointing issues that are occurring. As an example, you take an air handling unit. If you want to zoom down from the portfolio level down to a single unit in a single building, an air handling unit that has 30 data points can generate up to 3 million data samples in a year at the rate that we sample them. And that, if you had 1,000 of those assets across a campus or a portfolio, you're talking about 3 billion data samples right there in a year. So that's a lot of data that is available to tell stories to you and help you make your job easier, help you identify issues you may not be able to otherwise. And gone are the days that this is acceptable to be able to do this just using, BAS graphics and alarms. That's just, we've evolved beyond that, luckily. However, there are still many people that are doing just that, right? So managing alarm panels and using that as their main driver. Of course, that has its place, but this is not that place. So with all that data, what are we doing? We're asking questions of the data. So we're taking algorithms and we base those algorithms both on standards, but on best practices from engineering guidelines, et cetera. But you take the ASHRAE, 90 dot standard or the guideline 36 standard, and you apply, those analyses to that data in bulk. So you might have 100 of these units. You're looking at 100 of them continuously, over time. You're calculating performance metrics, you're identifying faults, asking the questions and flagging them. And those flags get generated as what we in our platform called insights. Of course, there are other platforms out there, they call them something different, but generally speaking, it's essentially a notification saying there is a problem here. I've highlighted, this is the insight management interface in Kaizen FDD. Just as a quick look, you have them organized by fault type. You have pumps that are cycling excessively, airflow sensors might be faulty. I've expanded in this diagram here, VAV dampers constantly at 100%. Very simple one, just to dive into that. VAV dampers open 100% for more than 95% of the weekly occupied hours, right? And there's 4 of those happening in this building. So what this generates is a notification that somebody then needs to go open up and look at and say, okay, what is this recommending? Well, it's saying, I should verify the damper control. Is it stuck? Is it manually overridden? Is it lacking airflow? So there's some recommendations here for the person receiving this to go and help them with investigating. First of all, flags it automatically, shows them the data. I could see that this damper was behaving slightly bizarrely already. So it was opening 100%, closing 0, 100, 0, 100, 0. Eventually kind of gave up. It just is open at 100% according to the data here. Very simple example, but just to highlight what FDD is doing. So with FDD, we typically were seeing anywhere from 5 to 30%, depending on of energy savings in an existing building, let's say. But it allows, and that depends on how well the building's performing, how well it's programmed, a number of other parameters. But really at a portfolio level, if you're trying to manage, hundreds of pieces of equipment or thousands of pieces of equipment, this strategy allows you to look at a portfolio level, at a building level, at a system level, and typically can help move from reactive to proactive maintenance. We can reduce reactive maintenance by up to 50%, if not more. Some campus customers, one in particular that I can think of, a higher educational institute, they had dozens of reactive HVAC and MEP calls in previous years, and upon working with FDD, reduced that to, they had 8 last year across the whole campus, across about 30 buildings, 8 reactive maintenance tickets that weren't uncovered through proactive means. So that's really what this is about. We'll talk a little bit about some of the downfalls of FDD and what prompted us to move into the automated commissioning and ASO realm. So FDD is essentially a data-driven decision support. So the workflow with that would be we collect data at site, we send it through the data acquisition and the independent data layer to our EMIS platform. The FDD module would work on that, would generate a insight or a file. That file gets sent over to somebody, whether that's our engineers who are working on managed services with the customer's team themselves. That workflow where then they validate it and then they get something fixed and then they repeat that process. So that is a data-driven decision support mechanism And what often happens is, there's a bit of a bottleneck sometimes here. The bottleneck can be the people, their ability, their time, etc. So that prompted us to move into the next realm of what we're doing now, which is automated system optimization and automated commissioning and testing. So the workflow now is very similar in that we are collecting the data, we are analyzing it, we are generating a notification, which can be reviewed by a human. That human can be either fully in the loop and approve each action, or they can allow the system, to essentially automate everything fully. And basically the resolution to that issue for some issues, of course, if it's a mechanical fault, a leaking valve, a damper stuck, then of course there's no automation that will fix that until we get robots that are going to crawl up into ductwork. But in the meantime, anything that is related to optimization, to do with schedules, set points, staging, etc., as we will discuss along the rest of this presentation, can now be automated from the supervisory platform down into the building automation system, shortcutting a lot of that back and forth and really enabling a much faster resolution and return on capital for these projects. So that's the kind of the historical perspective of, okay, we have FDD. FDD is a great tool. It's great for most people. These platforms are supplementary to FDD, or they can replace FDD or be there instead of FDD. And we'll talk about how that would work if we were to focus solely on the supervisory automation in some cases. I'm just going to update the graphical design, graphical workflow here. So what we're saying is we are still reading data through the same device. So if we have an FDD implementation that's in place and we want to do supervisory automation, in our current application for that, we add a second device. That may not stay that way forever, but for the time being, while the industry is getting used to this shift in read-only to dynamic optimization, we found it was better to add a second device which will handle the two-way interaction with the building automation system. And for various reasons, one of them is that we compartmentalize those. So we have the read device and then the two-way interaction device. And notice I'm not saying the write device because we're not always writing. We'll explain a little bit more about that in a moment. This second device we call KCOM. The first device is called K-Link. So the KCOM is there to facilitate the return of information from our cloud platform and then the interaction with the BAS that way. So it is there. It uses the exact same ports. Theoretically, there's no inbound traffic. So that device is always reaching outbound. The firewall can be set up in a very secure way. So we are continuously reaching outbound from the device, establishing a secure connection using a encrypted certificate, and then the information from the cloud is then brought down to the KCOM device for local action at the building. So that is the block diagram level for the architecture. When we start talking about where we're going from today, so today we're going to be speaking about both optimization using ASO, relying pretty heavily on ASHRAE guideline 36 sequences. However, we'll discuss some of the other options there. And then the open and closed loop functional testing that is brought to us by the automated commissioning and testing solution. And shortly on the horizon, we are moving this technology in a direction towards demand side management, and demand, grid interactive efficient buildings eventually. So connected buildings, right? What is the current grid conditions? What is my current demand? And what decisions can I make to optimize where energy is being produced, being used from, et cetera? With electrification and whatnot, this is definitely an area that will be very important going forward. So without further ado, we'll start talking first about the automated commissioning and functional testing, or ACX, piece of the puzzle. Now, ACX is an automated and enabling process. So what it will help with is verifying devices which are controlled by a building automation system in situ. So they're installed already in a building. They're, the process leverages both real-time data, but also if we have FDD and we have historical performance data there, it will leverage those engines as well. So adding ACX to an existing FDD platform adds a certain advantage. However, we are doing commissioning projects where all we are doing is ACX. There is no fault detection diagnostics present on the site. And that is typical of new construction facilities, for instance, where we are being deployed for a very short period of time in the beginning to enable the functional testing and commissioning of equipment, usually pre-formal commissioning. So we're making sure that everything is ready. We are exercising the systems in a way that is more thorough than would be done by your typical sort of process in the commissioning phase, which is contractor tests their own work, give a report to the general contractor or the commissioning team, and say everything's been tested. Yet when you get to the commissioning phase, the functional test and the commissioning is a sample, maybe 10 or 20% of the total number of systems that have been implemented within the building. It leaves a lot of room for error with regards to deficiencies. So it's independent from the commissioning team, although commissioning teams embrace this, and it allows, given the amount of time and resources that are dedicated to commissioning in the standard approach, it really is a monumental shift in the amount of testing and verification that can be done for the same amount of budget that you would see in a normal project. The ACX application, we typically focus on secondary or zone equipment, and I'll explain kind of why. But usually we're talking about VAVs, fan power units, fan coils, heat pumps, unit ventilators, air curtains, radiation units, reheat coils, etc. And the reason why Coppertree focuses on secondary equipment is we, in this world here at ACX, we are writing to systems. So we are leveraging writable properties in BACnet to write to outputs on pieces of equipment's controls, right? And what we don't want to be doing is turning on primary chill water pumps or enabling a chiller, for instance, or a major piece of equipment. We don't want to do that because there's some liability in that for us. That's just much more prone to faults or things happening within that. What we can do though is by targeting these sort of less critical pieces of equipment and only writing to very specific things and getting them to do things with that, we also get to test that primary equipment, but we get to test it under sort of real world scenarios where we can simulate load in a building or ask all the zones in a building to go to a certain temperature set point and then watch all of the equipment all the way upstream and downstream react to that. And with FDD, if it is deployed on the primary equipment during that time, we then catch the faults that we see through that. So for instance, I'll give you some examples of a VAV test that we've done. So that is the strategy behind the ACX piece. Now keep in mind there could be 1,000 VAVs in a new construction project or a large existing building. It's not always about commissioning, it's also about maintenance. So we'll talk a little bit about that. This might be a little difficult to see, so I'll kind of read through a few of these. These are ACX secondary system tests that we perform using the Kaizen ACX platform. So I'm going to show you damper, feedback, mismatch, leakage, and response tests as an example. But we also are looking at airflow, fan control, heating and cooling control, reheat valve mismatch, feedback mismatch, leakage from valves, response for valves, and as well as reduced or limited cooling, so there's cooling and heating, I suppose. There's a whole bunch of these tests that we are performing applied to every one of those types of systems as they apply. So obviously for a heat pump, we'd be exercising its cooling function. Is it reaching set point? Is it sufficiently cooling? With valves, actuators, and dampers, we are exercising those to see if their feedback makes sense, if there's leaks beyond them, etc. So if you picture this times hundreds of systems, each one of these tests being applied and run, it is a lot of additional testing beyond what would be normally done with the traditional process. So to give you an idea of how that looks in our Kaizen system, this is a real deployment. I've redacted the client's name, but you can see what we do is using our systems tool, which allows us to group and contextualize the data. So we onboard the data from the building. We identify the points that are associated with VAV zones in this case. There are two main groups of VAVs. I've expanded one. The first group has 57 VAVs. The second group has a number as well. Typically each one of those will be either on a floor or served by a common primary unit. We can organize them how we wish. we then tag them in a certain way using our automated tagging process. So we say this group of VAVs is going to be a test group. That means we're going to exercise damper control, heating control, HVAC mode, and sequence enable. That's the 4 tests that we have here. We're going to do all of those, and we're going to run those simultaneously on all of those that test group. So it's very flexible in how we want to organize the testing. Once we have it organized, we then initiate the tests. And so I'll give you a graphical view here of what a test would look like. This is a VAV actuator sort of, and damper control leakage test. So essentially we have that group of VAVs that's tagged as a common test group. They're in auto mode, happily cruising along. This could be either a commissioning project in new construction, or it could be an existing building where we want to test the performance of the VAVs periodically. So during the preventive maintenance process, do we want to supplement that with either seasonal commissioning or with periodic monthly tests of every piece of equipment in the building, however often we want to do it. And again, it's just as easy as scheduling that in the application and saying, last Friday of every month, I want to test all the dampers, this part of the building. Second to last Friday, I'll do this part, et cetera. But what the test is really going to do is we are commanding the actuator tests, or commanding them to go to 100% open. Usually we coordinate with the client so that the main plant is on and enabled. Therefore, that plant will react to the request. So we're saying everybody go full open, ask for full airflow. So everybody responds, theoretically, opens to 100%. Then the next stage in the test is everybody go to 0%. That's phase 2. The next piece of the test in this particular test script is everybody go to 50% open. And then the next one is everybody go to unoccupied mode and we release control. So in BACnet, we relinquish control. We are writing at a very low priority as well. So if there's any other thing going on in the building, we are lower than a manual override. We are lower than all safety requirements, et cetera. And so this whole test takes 45 minutes to execute. And theoretically, you could do this on hundreds of VAVs at a time. But we're doing, in that test group strategy, which we predefine with the client. So now we've run that test for 45 minutes. We have a really good idea of which systems performed and which ones didn't. And I'll highlight a few here, but I'll show you the resulting report. Not only does it generate insights in the Kaizen interface, which are available through the API, we can push those into a CMMS, into Maximo or other platforms. But not only that, but we generate these custom reports. There's an executive level report. This is the more detailed one. The executive level one will show things like we ran, X hundreds of tests. We had this pass fail percentage. These are the systems with the most problems. In this case, I'm highlighting a page here with 2 issues, VAV 0816. It passed airflow and damper feedback mismatch and leakage, but damper response seems odd because it describes to you and gives you the actual value. So it's saying that we had a higher airflow measured when the damper was at 50% open than when we did when the damper was at 100% open. So there's something curious going on. Now, of course, if you open this up in Kaizen, the interface, it gives you all the data for it. You can see what's happening. But that becomes a deficiency if you're in commissioning, or it becomes a maintenance issue that you would then schedule to go have addressed. Rather than, let's say we did 400 VAVs in this building, the traditional maintenance approach would be, spend an hour or half an hour, however long, every 6 months, look at these, 200 VAVs, every other 6 months, look at the other 200 VAVs, and spend a whole bunch of maintenance time inspecting, looking at them, stroking dampers and saying, well, that one looks okay. Whereas now we're saying, we'll just test all of them. We could do it monthly. Theoretically, we could do it every day. Of course, we wouldn't do that. But the level of detail that you get and the ability to not have to do that sort of less valuable inspection and maintenance frees up the team, whether it's a contractor or it's your own staff doing the maintenance or the commissioning in a new construction context. It frees up everybody's time to focus on the problem and not focus on looking for problems. And the difference really between this and FDD is in a listen passive mode where we're just waiting to find problems. So we're waiting for things to happen, whereas this is like, I like to equate it to, you go to the doctor for a physical and they put an oxygen mask on you and they make you run on a treadmill to figure out your VO2 max and have a heart monitor on you the whole time, right? So we're exercising the building, and this can be used for things such as design day simulations, right? Let's go everybody to full cooling and crank those set points way down. And we can do that in off season as well. So as the cooling season's approaching, do we want to simulate the load that will be present in the real world and see what happens with the system, catching those issues, getting them resolved before we're into a design day scenario and it's summertime and everybody's complaining about the cooling. So ACX, whether used for commissioning or ongoing maintenance, is really that next evolution of how things work. So just to give you an idea of kind of the project process of how things typically roll out, the first step is optional. It is to implement FDD. So if you have FDD already in your building, you've got all the data, everything's ready to go, we are able to move, with confidence. We know exactly what we're up to. We know all the systems are already mapped, they're already tagged. We can move into developing the plan. In the case of a building that doesn't have that, if you want to start with ACX, that is also okay. However, you only get the ACX testing, and you wouldn't have visibility necessarily into the primary equipment performance, which is available through FDD. So you'd see the faults at the zone or the secondary equipment level, not necessarily at the primary equipment. So what we would do is we would deploy FDD first, if not already deployed, optionally. But either way, we develop an ACX test plan. So we identify all the systems in the building, and we make recommendations of which systems we will test with what tests. We discuss that with the client, and we come up with a pretty formal document. So there is a formal test plan. It identifies specific white list of points that we are allowed to target with our ACX testing, which outputs we will write to. And which tests we will conduct when. We make sure the plants, central plant will be enabled as required if there's dependencies there. That plan gets ratified and approved by the client. We then proceed with the, implementing those ACX tests. If this is commissioning, this is all pretty rapid fire because usually we're getting involved and the systems come online, and we want to be able to implement the tests and run them during the commissioning phase to provide that feedback to the commissioning team and the commissioning agents. So once they're grouped, we schedule the tests to take place. We report the test results, communicate those to the client or the contractor team, depending on who we're working with. And then we move in, if it was a commissioning project, we then hope that that continues on through maintenance through the warranty period. But if it's an ongoing maintenance type of approach, then we would look to reduce the preventive maintenance budget, enhance what the team is using as far as their maintenance targeting, and then hopefully expand the ACX to additional systems or additional buildings within the portfolio, and rinse and repeat essentially back to that first step that we started at. That's a typical ACX process that we see. ACX in action, I want to show an example case study. So we just recently deployed ACX to an existing US government agency facility. It was part of the commissioning stage of a renovation project. So what they were doing is adding 100 VAVs to an existing HVAC and BAS system. Of course, you can think of a few things that could go wrong in regards to having an existing central plant system that now has to step up and feed these 100 new VAVs. On those 100 VAVs, we performed 1,100 distinct tests during that initial period. So that's a very short period of time, but we were doing that many tests. 83% of systems passed all tests conducted, meaning that there is 17% of them that didn't, right? And these were systems that had been well programmed by a very capable contractor, but this is the reality that most projects we find in new construction or in retro or in renovation find themselves, and even more so probably in the ongoing preventive maintenance projects. So several systems were experiencing low airflow, damper leaks, and room control faults that we're able to identify through ACX, and also able to identify the fact that we believe the building's balancing needed to be re-looked at. It was probably not properly balanced to support the extra 100 units that were being added. So that was a major takeaway, that just because you add brand new VAVs, there's a possibility that you still have airflow issues, of course, downstream, and so that's something that needs to be looked at holistically, and so that's a good way to catch that. And all of this was performed fully remotely. So Coppertree never steps foot inside these buildings. We ship our device down. In this case, there was no FDD added to the project. It was completely for commissioning. We deploy one unit, pull the data. In a matter of a week or two, we're up and running and ready to install and run the tests to support the commissioning team. And this is only 100 VAVs. You could picture, if there was some of these smart hospital projects we're doing have 1,000 or, several hundred VAVs. You multiply that number of tests, and you don't just do it during that commissioning period. Ideally, you'd be running it throughout the warranty and defects and liabilities period. So generally, we're estimating, and from the projects we've done this, about a 20 to 40% reduction in labor for commissioning and maintenance of the secondary HVAC systems, depending on which items you take out of your PM program in favor of this data-driven method. And that's something we would discuss and we can plan as part of our advisory services to help you get the most out of that. I'll also mention there's a lot of end clients who are interested in negotiating their maintenance contracts with their service providers. I know that sounds like a one-ended, sort of goal as far as like, let's reduce the cost. It's not necessarily about reducing the cost. It's about improving the efficiency of the maintenance. So can we actually have those technicians on site doing more meaningful work for the same amount of budget, parts and smarts, efficiency upgrades, et cetera, rather than spending time on the end of a ladder, moving ceiling tiles and looking at systems that don't need it. So ACX is a big part of the evolution of where what we're heading with, and ASO being the next main topic for today's presentation. And ASO is quite exciting too. So ASO is a software interface that augments how building automation systems interact with cloud platforms. So obviously the cloud has a lot of processing capability, has a lot of ability to crunch data, quite a bit more so than building automation systems, which are designed to be inexpensive, right? So it is edge computing. They are designed to be very cost effective because there are hundreds of units in a building. And we still haven't seen the building automation system market catch up to adding that much power at the supervisor, let's say locally, or we're starting to see trickles of AI coming into the industry from a supervisory application. But ASO enables continuous optimization through that interface to a very powerful cloud system and the building automation system, which is designed for real-time control at the building for the most part. So in ASO, the in-target systems typically are more the central plant equipment, although we do leverage data from the secondary systems to calculate demand and to provide inputs to those optimizations. Normally, we are targeting energy savings with the ASO platform, and we are targeting the primary equipment, so chiller plants, hot water plants, air handling units and airside systems, RTUs, makeup airs, cooling towers, et cetera. But of course, we are informing the application with data from the demand side, because that really, as it'll become evident in my examples, is important data to have as well. So the ASO, it is, in our particular case, there are of course other applications for ASO in the market, but in our case, our primary optimization measures are based on ASHRAE's guideline 36 standards. It doesn't mean that's the only optimizations that we can enable. It's just given where the industry is, and frankly, some of the the raised eyebrows we get when we come to talk to a client about cloud-based supervisory automation. It's nice for us to say, by the way, what we're implementing is ASHRAE guideline 36. It is this standard on this page. Every controls contractor, every engineer should be familiar with this, or at least learning about it now as we go. So. That is one of the reasons that we have started with ASO and are deploying guideline 36 optimizations, which I will show you about now. So again, might be hard to see these. If it is, we can share this information out, and I'll go through some of the optimization sequences. So the first, I'll show you more of an example of a discharge air pressure reset strategy. And that'll be a bit more of detail and kind of a screen share that I'm going to show you. But in addition to the air pressure resets, we're doing cooling discharge air temperature resets, heating discharge air temperature resets, leaving chill water pressure reset, leaving heating water pressure reset, leaving chilled water temperature reset, leaving heating water temperature reset, chiller plant staging, hot water boiler plant staging, fresh air damper low limit resets, fresh air damper high limit resets, unoccupied heating and cooling set points, and zone airflow reset, so demand controlled ventilation. So those strategies, while not, I like to say we're not reinventing the wheel. These are strategies that many of our clients have in their BAS. It is possible to program these. We see them in designs, especially in net zero buildings and whatnot. However, most existing facilities will not have these sequences deployed. And part of the reason for that is that they are expensive to deploy in relative terms. They require a lot of memory, a lot of processing power, and the building automation system isn't always the best place to do these, especially if we can do them on a cloud solution where the power for processing is essentially unlimited. So those are the standard optimizations. Again, back to the previous slide, we can do other custom measures and we can design any one we want. So if you were interested in a particular optimization, might be particular to your campus, your climate zone, et cetera, happy to speak with you about those. Changing these measures is, if you're familiar with our logic builder, is very similar to programming algorithms in our logic builder. So there's nothing there that is very difficult. However, these are the guideline 36 strategies that we have implemented so far. So how does it work? There are two ways for this to work. The one way is what we call a push strategy. Our device that we'd shown previously in the architecture diagram is on the BAS network. It is reaching out and connecting to our server and asking it for the optimized set point or the optimized position or damper or whatever, and it is pushing that into a variable within the controls program for that particular piece of equipment or program. So continuously reaching out every 5 minutes, typically, getting the process to optimize set point and then pushing that into the BAS, into a variable that is there for that. So that is really good if this uses a BAS write access. It's very good if you don't want to have to deal with setting anything up on the BAS and you're okay with Coppertree doing it this way. We do have some clients who don't prefer this way, or controls contractors who say, we're not super comfortable with that. We can certainly talk you through exactly how this would work. But we also have a pull strategy. And the pull strategy requires a little bit more BAS work, I guess, or it requires some BAS work on the side of either the client or the BAS contractor. But it does not require BAS write access. So it is a way to optimize continuously every 5 minutes, the same mechanism that we would use, with the one difference being that it doesn't require any write access. And I think that should say option 2 for ASO optimization. So this is really good for folks who have a secure environment that are very very locked down, let's say, in their standards for their building automation system. Not that every client doesn't have a secure environment, but maybe particularly concerned. Or if there's a building automation system capability within the client infrastructure, within their team, or their controls contractor. And so we would enable that work to be done using that team or that contractor in a way that doesn't require any write access to the BAS. And that's quite different than a lot of solutions that we'll see on the market. You've probably heard of several AI solutions out there that you hang a box on the wall and magic, it's going to optimize your building for you. And our belief, having come from building automation ourselves, from working with so many clients, there are very few people in the whole value chain, from the client all the way to the contractor to the engineer to whoever, that really want that in their building. They don't want something that is just a black box sitting on the wall that's going to be overriding things on the BAS or writing to things on the BAS. And either one of these options, whether it's the push strategy or the pull strategy, is very it's very open. We exactly define the code, what we're doing, what strategy we are using, where we are targeting, etc. So everything is very open in our approach versus the black box AI-based optimizations, where it's the complete opposite. It's very sort of opaque. You don't really know what's going on. So when an issue happens in your BAS network, we can very quickly say, well, look, this is all we're doing here, and that has nothing, that's not our issue. Whereas if there is something that isn't so clear, it does create a lot of potential for disagreement and sort of blaming, etc. So Coppertree didn't want to be in that position, and knowing how the industry works, we felt this approach, either one really, because of how open it is. And we play with standards and we use BACnet, and we can exactly pinpoint the actions that our system has taken. So to give an example in the real world, this is a real building. On the left-hand side is a typical discharge pressure set point control sequence visualized. And I'll explain it a little bit. So we have a status, a startup time. So the discharge fan status turns on at whatever time every day. You'll see that the discharge air pressure is reading 0. That's good. They're turning it off at night, so we can't really complain about that, but at least they're doing that, right? But it ramps up to, this is inches water column on the left-hand axis here. So inches water column, 1 inch water column, it stays there all day and it's modulating and it turns off at the end of the night. And so it will do this, it'll achieve this, pressure by modulating the variable frequency drive on the fan, right? So it'll say, okay, I need more fan speed or less fan speed. I always got to stay at 1 inch water column. And the reason why is because there's some balancing report that was either done in 1986 or last week, whenever it was done, which the test and balancer said, okay, well, the ideal, based on all the balancing we've done, this is the discharge pressure set point that we need to maintain in order to assure that end of line pressure gets maintained on a design day in the middle of August, right? So while the efficiency comes from modulating the fan speed in order to maintain that 1 inch water column, the question should be, is that 1 inch water column necessary, or should we be not doing that? And looking at all of the demand side. So what we do is we look at the demand side. So in comes ASO, and what we're adding, you'll notice there's no line on the bottom here. There's a green line on the ASO side. We're adding this point to our system. Essentially what that is it's an aggregated and calculated zone pressure request every 5 minutes, because we are polling all the damper positions of all the VAVs that are being served by this compartment unit. We know how much air they're actually asking for. So, what will happen on the left-hand side is there will be, very little demand, let's say, for airflow or pressure. So the dampers will be fairly closed, yet the fan's maintaining a 1 inch water column pressure. So on the right-hand side, we're saying if there's very few, zones asking for more pressure, why not continuously just relax that set point down? So keep modulating that fan lower and lower, so that when we get to a point where there's, I think it's 3 or 2 or more zones are starving, then stop. And if it goes more than 2 or 3, then slightly increase the discharge pressure again. So it's known as trim and respond. It's not anything that we're inventing. Again, this is a ASHRAE guideline 36 standard. The difference is that to implement this standard and this sequence in the controls, you of course need to have your controller going and reading from, let's say 200 or however many zones are in the building at any given time, calculating what's the damper position, bringing that into your sequence, looking at that, calculating what the optimal set point for discharge pressure is going to be, how many are starving, how many aren't, adjust the sequence. It can be programmed into the BAS. It is, of course, something that happens especially in new buildings. But in an existing building, to accomplish this, it takes about 8 times more code, according to ASHRAE, than it would take to write the sequence where it says modulate fan speed to maintain 1 inch water column. So in the case of a 200 zone building, if we're doing ASO on the relative compartment units like this, we would be calculating 56,000 or 57,000 calculations per day at 5-minute intervals to give a 5-minute updated discharge pressure set point. And that's 21 million data calculations in a year on one measure in one building, right? And the BAS could do a couple of these, but eventually you're going to get to a point where you can't do all guideline 36 sequences unless you, again, brand new BAS, super lots of memory, maybe you'd be able to do it. In a retrofit application coming into an existing building, try to deploy this would be a fairly major controls job. So as an example, what we typically do, and ASO is much more reliant on FDD. So we need FDD. We don't need it, I guess, but we like to have FDD, and we do implement it first because we don't want to blindly go and just try to optimize things that might already be optimized. Of course, the drawings, the sequences, the mechanical schedules will help inform us what we can do, but we like to implement FDD in a listen-only mode for a period of time and evaluate the performance of the building and the building automation system sequences. that helps us to identify the impact that the ASO measures will have, which ones we should be deploying in each building. So that period can last anywhere from a month, 2 months, 3 months, something like that, if we're in a bit of a hurry to do it. If you have an existing FDD application, this data is already there. So we would be able to come in and hit the ground running with proposed optimizations right away. We take those proposed optimizations, we develop an ASO control strategy plan. We submit that plan for approval. Sometimes the building automation contractor is involved in that discussion, the consulting engineer, the end client's team, of course, depending on who we are working with. And we finalize that plan. We then initiate the ASO, which typically could happen on, let's say, a subset of systems. Maybe one building, we want to do a couple of floors, one primary piece of equipment, et cetera. We deploy, we track and validate the optimization measures. And then we move to the next stage, which is measurement and verification and expansion. So measure and verify. We thought we'd be able to accomplish optimization through chill water leaving temperature resets. We did that. There were no complaints on comfort. Look at the savings we've achieved through the energy modeling that we're doing through Kaizen, and let's rinse and repeat that. So now we're ready to expand that to other buildings in the portfolio. And this whole flow can just rinse and repeat again across multiple buildings. So the difference there is that there is far less back and forth, far less let's deploy capital for humans to go and do things. Let's get the controls contractor in to help us program and do all this stuff, versus let's let the cloud do the calculations and simply deploy a single variable down to the building that's going to enable that optimization. So the amount of capital, so to speak, to be sent deployed alongside of this is far lower. I'll give you a real world example. Class A office building, 500,000 square feet. In Toronto, it was well maintained, very energy efficient. We achieved an annual energy savings of $45,306. And that was, not all the measures. That was only a single or maybe one or two measures across airside systems within the building. Additional measures are ready to be implemented now. The client has seen the light, so to speak, and we expect a total energy reduction of 20 to 30% once we implement the rest of those. So we did compartment unit economizer optimization. We did do some chill water pump speed control improvements and fan speed control improvements, as well as some staging and speed control optimization. So 4 measures were implemented across the building. But we expect that with the application of all the other ones, we've already modeled out a 20 to 30% full building optimization in energy. With pretty much no capital. So there was there's no requirement for capital to be deployed. We're not upgrading HVAC systems. We are fine-tuning ones that exist already in place. And these numbers are pretty in line with what you might see from Guideline 36 sequences as they compare to traditional sequences anyhow. So, there's lots of documentation online around Guideline 36. That was the case study, and typically we do see an average of 15 to 30% continuous energy savings across systems where we deploy the optimization strategy. And portfolio-wide optimizations this way, if you have one BAS vendor or supplier in 3 buildings in your portfolio, another one in 5, another one in 10 more, getting these deployed in the same way across all of that, managing all of that across each different vendor, and getting those sequences programmed across 3 different building automation system types creates a lot of room for cost and error. And being able to roll this out to any BACnet system. I should mention BACnet is required for ASO in order for us to create ASO optimizations, and it also is required for ACX. So both ACX and ASO require an underlying BACnet system, because we are, in the case of ACX, writing to outputs, and in the case of ASO, to variables if we're doing a write, or we're providing variables to the BAS for optimization if it's a pull strategy. So those are the typical sort of things that we're seeing along the lines. I'll open it up for questions. I don't know if there's any on the online poll. However, if anyone feels like asking questions live, I will be able to unmute the audience now as well. So let me just go ahead and unmute everybody. If somebody would like to, let's see here, unmute all. If anyone would like to go ahead and talk. Oh, looks like there's somebody with a hand up. Okay, everybody's unmuted. Should you wish to ask questions, the mic should be open for you.
Can you hear me? Is it
I
coming through?
can. Yep.
Yeah, just a quick question about some of the copper tree devices. So we do have copper tree at in our organization, and we're using the copper cube product, which I
Yeah.
guess is now obsolete. So my question was the K-Link, it doesn't do data storage for trend logs the same way that the Cube does. That's what I've been told. Is that correct?
That is correct. Yeah. Yeah.
Okay. So and I've also been told there's not really a direct kind of replacement for the copper cube. That's also correct?
Well, that's not correct. I mean, I guess I'll ask first, is your BAS Delta?
Yep, it's
Okay.
Delta.
Yeah. So what we've done now with Delta is there's the IntelliVault product, which is a
Yeah.
server-based archiver. So we have
Okay. Yeah.
created we've created an integration for the IntelliVault product, both IntelliVault and IntelliCloud, which is a cloud-hosted version of it, where we pull the trend. So just like the Copper Cube used to push the data directly to Kaizen,
Yeah.
we pull the data out of the API on
Okay.
IntelliWeb's IntelliVault, and we then push it up to Kaizen. In that
Okay.
case,
Yeah.
we do still require a K-link sitting in parallel with the IntelliVault,
Yeah.
and
Yeah.
it is there. It is there essentially because the
Okay.
IntelliVault doesn't have a network address translation kind of method to push the
Yeah.
data out to the external
Okay.
world. So we house that behind the firewall, and it is reading from the IntelliVault and pushing the data to Kaizen.
Okay.
Same as it's actually the same ports. It should almost be a plug and play for what you had with the Copper Cube.
Okay. All right. Yeah. No, that confirms kind of what I'd been told. So no plans from you guys to come out with a newer cube or replace the cube.
Uh, yeah, not for like archiving trends to make them available to IntelliWeb, for instance, because Delta's already
Okay.
got that covered, right? So in the case of so going back to sort of part of my discussion, we are seeing more of a push. I'm just going to flash back to a couple slides here. Sorry, I'm probably giving people seizures here with the flashing, but when it comes, so this slide here, we're seeing the IDL layer really being that now. So rather than have it
Yeah.
sitting on a physical device, worst case, the cloud never goes, it never breaks, the hard drive never fails, right? And if it does, it's on AWS. So we have it it just switches over and it's there. So that IDL layer now is kind of what we're seeing people move towards versus
Right.
storing it locally
This
on a
is just the
device.
cube is just kind of something from the past, I guess, and
Mhm.
we're moving on, right?
Yeah, yeah, I know. I love the cube too. It's hard to say goodbye, but yeah, I mean the advantage of
This
the
is so
yeah
handy. Especially for
yeah
my trend logging, right? I love
yeah
to use Copper Tree for that, and
yeah.
yeah. Anyway.
I would say same approach. I mean, the K-Link actually doesn't require trend logs, so we are pulling. Let's pretend it's we can pull the trends still, so we can still pull the trends in and push those up if they exist. But we can mix and match. We can pull some trends if they're trended. But let's say we never trended airflow points. We could actually, or other buildings where it's a third-party BAS. Maybe you have another vendor. I don't know, but
No.
we can go in there and pull. We can pull 40,000 points out of the BAS without any trends being added to them. So in the case of that, there's definitely advantages over the Copper Cube. Yeah.
Gotcha. Okay.
Yeah. Mhm.
All right. Thank you.
You're welcome. Thank you. Any other questions?
Keith, one for me. It's Mike here from AIS.
Hey, Mike, how you doing?
Very well, great presentation.
Thank you.
Just off the wall one with the ACX approach for maintenance, in particular fan crew unit controllers, VAB controllers, on an existing installation where the device is installed behind a firewall that's particularly well sealed, let's say.
Mhm.
I get that it's got to be written to or have a direct link to the Copper Tree servers, right? But is there a way we can put some packages into an existing edge device and run them locally?
Run them locally. Potentially, I guess that could be something we do at some point. Right now, so that is something we're investigating, Mike. Right now, that's not the case, but we are looking at a standalone option where the edge device might be able to do more of it on its own. The user interface, though, and the command of all that is usually done through Kaizen. So I guess there's two parts
Yeah.
of answer. We're investigating that. Secondly, the firewall requirements are actually no different than the K-Link. So if they're allowing outbound traffic to our server, that's all we need to be enabled. We're not actually pushing any data in. It enables, basically, it reads out, it establishes what's called related established communications. And so unless they're very, very strict on their firewall, like they have deep packet inspection and all kinds of stuff. Another option is you put the KCOM in a DMZ or a proxy. So there's definitely ways. I think maybe get in touch, Mike, and we can talk through some of those options.
Cool. Okay, will do. No problem.
Yeah, thanks for
You'll
staying
know
up
the
late.
customer that's particularly no problem.
I do know.
Well worth it.
Yeah, for sure. Thanks for staying up late too. It must be quite late there, so appreciate it.
Yes, more about 9 o'clock now. Not too bad.
Yeah. Other questions?
Sure. I work for an energy efficiency program, and a lot of times we need to have an understanding of what the baseline activity is
Mhm.
relative to the optimized activity. And so if the system is perpetually evolving in order to support continuous optimization, is there an ability to sort of freeze the system in order to collect a baseline data set and then an optimized data set? Like, how would you go about doing that in order to apply for like an incentive?
Yeah, exactly. Good question. 100%. There is an ability. So this is an M&V report. So what we do is we have the previous behavior of the system. So each measure, like let's say this is an ECM implementation that happened for compartment unit economizer, for instance. This is the ECM implementation date. We have the before and after functioning, and all this data is tracked and stored within Kaizen. It's available in CSV. It's available for export. It's fully exposed. So then when we do our calculation around the achieved savings, we have the implementation date that we applied it, and then we have the pre and post optimization data in a lot of detail. Like we're doing this, there's the baseline fresh damper position. There's, so we basically go through that, and the calculations are all created within Kaizen to be able to support that before and after snapshot. Hopefully that answers your question.
New question.
Yes, please.
Do you have any business cases you could discuss talking about the return on investment or net present value or efficiencies gained to justify the cost?
Yeah. So I can tell you, when we go to save, let's say we achieve a 20% energy savings in a building, our payback is in weeks on our platform. I can tell you that much. I think if you want to dive into a little bit more on that, we could take that offline. You can reach out. We can give you some very specific details around that. But because of the low touch required in order to implement these versus what are typical, if you're talking about ASO, the ACX piece would be a pretty simple calculation around what maintenance measures am I going to replace with automated commissioning and testing. So if I'm going to stop inspecting my VAVs every 6 months and I'm going to only repair ones that are showing as broken, what portion of that dedicated budget can I remove from inspection and put somewhere else or get rid of? That would be that pretty easy calculation. When it comes to ASO and we're talking about energy, I think we'd include that. We include that expected savings in the ASO plan. So as we run the baseline of how it's operating today, and then we propose the measures, those measures, we can accompany those with the projected savings associated with them. We're toying with the idea of shared savings, those kind of ideas. It's not something we've done before. Usually our customers would be more in that kind of world. Maybe they're at ASO or a shared savings provider. We're thinking about that. It's something that we're curious about, I suppose, because there's so much opportunity for us to leverage the savings because they're so high. So I would say very fast return on investment and return on capital compared to what you might pay for such an upgrade to happen to the controls in the traditional manner.
Thanks.
Happy to take that offline with you. Yeah.
Okay.
Any other questions? All right, doesn't seem like it. Oh, it looks like there was a question here in the text for that last case study with 20-30%. What was the simple payback of the project? Okay, I believe that one was in a couple of months from payback wise. So it wasn't very long at all. It's a very efficient way to optimize the building. If we're talking about simple payback, right? So we're talking about our costs. We're not factoring in IT time to get things connected, et cetera. That's not included in our simple payback numbers. Okay, I think that was the last of, there's a bunch of questions here maybe in the chat. Maybe I'll just go look through those. For ASX, what to extent can your service verify that sequence of operation have been properly programmed? Also, what are the current limitations of your ACX service? That's a good question. So yeah, we can essentially mimic the sequences. So we would look at sequences both on the primary equipment and on the secondary equipment. The limitation being that it has to be backnet. We have to be able to write to outputs on those secondary pieces of equipment. I'd say those are a couple of limitations. Right now, as per Mike's question, we are needing it to be cloud connected. So we need some interface with the cloud. So some ports need to be opened, et cetera. As far as testing the sequences, what we can do is we can generate conditions which would lead to that sequence being enacted, right? So we would say stuff like, theoretically, we could just, we could simulate demand, as I mentioned, simulate cooling demand. And that should therefore, maybe we lower the cooling effective set points down really low, and we see what happens with regards to the sequences, both on, on the primary equipment, but all the sequences along. So give you an example, if we do open everything up fully wide, let's say we create a full airflow situation, and the sequence says that fans will run at a certain lead lag, or pumps will run at a certain lead lag method, and when the first one reaches 90%, second one's going to kick on, and then it will run until you get back to delta pressure of X, and then it'll shut off and go back to standby. We can exercise that whole thing and see if that's really happening, because a lot of times we see those things don't happen, right? We have a fan that ends up running at 100% and the second one never kicks on. Things like that. So we can definitely pseudo exercise the sequences on the primary equipment. And that helps us a lot with the new commissioning in particular, I would say, or retro commissioning approach, where we're trying to validate whether what was designed on paper actually got implemented properly. And the interesting thing about those faults is that they don't surface very often, right? Like that's not something that you often can catch that easily in commissioning, because the conditions aren't there for that, right? You might be commissioning in summer and it's a winter heating fault that you're gonna catch, where it has to do with boiler staging or hot water pump sequencing or something. So we can simulate those conditions on the off season or on demand. So that hopefully answers that question. What else do we have here as far as questions go? I think that might have been the last one. Oh, there's some more.
I have
maybe.
A quick one for you
Yep.
about the construction phase. We have a lot of owners asking us to overlay machine learning on top of the punch list. And some of them don't know how to ask for software to overlay the building automation system, but we understand that their goal is to just shake out more bugs before turnover.
Yeah.
Would your ASO product or the ACX product be a more valuable tool during the construction phase?
Yeah, for sure. I mean, I don't know what ML. So I guess it comes down to ML, right? You're talking about ML or AI, and everyone's always using those things. For me, what we want to do, because nobody wants to add more, like in the construction phase, everybody's just validating depending on if, again, if you're a design build contractor, or you're just doing construction management, or you're a, MEP subcontractor or controls, like, you're not going to sit there and be like, I have a better way to do this than the design engineer came up with. Like, it's really not the phase we're in at that stage. Like, we're basically saying, okay, the design, we're going to trust what's happening there. We're not here to tell you, hey, we have a better design for how you did that. It's more about validation and quality control. So it's shaken bugs out, like you said. Has the thing that's been designed ended up in the end product? Yes or no? Then there's a warranty period. At that point, if they're open to it, we have real data about how the building's operating. Do we want to start talking about optimizing stuff? Yeah, okay, maybe, but usually it's going to be post-warranty, or it's going to be, in an existing facility as a retro thing, where we're going to look to maybe ML would be better there. There's a better way to do this, right? But for the most part, we're essentially validating and verifying that things that are designed are actually showing up. And are there bugs in there? I mean, we see, end of line unit is factory program still. Nobody, we forgot, or it got reset somehow, and it's, it's a rogue zone. It's doing whatever. So there's stuff like that that just naturally get missed out of those 400 boxes that you've had to do. That's where we see the new construction, and that's ACX that would probably find that most. Whereas ASO is really focused on optimizing. And again, we haven't found a lot of interest in, optimizing the building as we turn it over pre-substantial, right? That's really not in anyone's kind of best interest, because they want to see how it's going to perform when it's as designed before they go and make changes to it. I think that's pretty common across the projects we see. Hopefully that answers the question.
One more from me, Keith. Sorry, Mike again.
Yeah.
Just looking ahead on ASO, we've got some target energy ratings and building energy ratings that the consultants have to design to here in the UK. And is there a way of putting like a profile together at the start of an optimization period that the building was designed to do? So, like, your template, this is what we expect overall for the building energy rating, then do a mismatch comparison overall.
Yeah, like in the future, I mean, if we have the original sequences and there's been no official updates to those, then that becomes kind of our basis of design, right? We have that. And then we can see, like, first of all, is it doing what it was designed? Probably not. Over time, this dial gets turned, that gets changed. Sometimes those things are documented very well, or if at all. So there's that whole, like, is it the way it was, or what's different? And then what should we be doing different to optimize? I think those are kind of two distinct phases that we can go into and use the data for sure. That's definitely a use case that we've been using it for. And from there, the option is, do we want to, because some of this is looped into kind of broader decarbonization discussions where there are upgrades happening. So they are electrifying and they're adding heat pumps for this or whatever. So there's a lot of moving pieces potentially within that. So yeah, I think what you're mentioning there is, are we the way it was designed? Probably not. Do we want to bring it back to that first, then from there, see how we're doing? Or, there's all those kind of discussions that can happen along the way. And, I skipped over the EIS platform, the Energy Information System, but weather normalized energy consumption and calculations fall pretty heavily into this. Of course, Kaizen has that built into it. I didn't focus on it today very much, but this level of EIS kind of, baseline electricity consumption, we do kilowatt hour fan rated power times baseline speed, root cube times duration. That's all handled within the EMIS platform too, so that we have that baseline and then we have that new approach. And I know Neighbours is coming to the UK. Neighbours is in Australia. We've been doing a lot of Neighbours reporting and work in Australia for years and years. And so that's something that standard, and there's other standards coming in. And LEED V5 also includes a lot of monitoring-based commissioning requirements, a lot of regulatory, or not regulatory, but standards that are going to be required. And I believe FDD is very much featured and prominent within that. And many utilities are also now incentivizing FDD as they always have, but there's separate kind of carve-outs for ASO. We're starting to see that more, where we have ASO as a separate incentive program for the utility programs that are incentivizing. That's more in North America. I'm not sure about the UK.
Thanks, Keith.
Yeah, you're welcome, Mike. A couple other questions here. Will all dampers close together with an AHU running, or will it do a small groups of dampers? That was from Animesh. So yeah, just if you're reviewing this, and I'll email you as well since you've already left, but that depends. So that's part of the test plan. We come up with the test plan in conjunction with the client and looking at the drawings and what data we have available for the system. So the last thing we will do is, we're not going to, run air handling units at full throttle and then, close all the dampers necessarily. I mean, that might be a test you want to do, but we might overpressure the ducts or whatever. So whatever safeties are built into the BAS, by the way, we are not touching, right? So if there's safety mechanisms and thresholds that are implemented, and they should be, and they hopefully are, but that's a good thing to test to or to know. But we would check that before we go ahead with any tests, and that's something that we do regularly with the ACX application. For instance, making sure that the interlock between the systems is functioning as we expect. And there's always safety, fire damper control, et cetera, that's going to override. Again, I think we're writing at priority 16 on BACnet, if I'm not mistaken. Don't quote me on that, but it's very low priority that we're doing. So anything that would be built into the BAS as a safety would take precedence. There's a question here from Keith. When using ACX as part of a commissioning routine, how do you take care of the comms? Typically, a new building site comms can be an issue. Thanks. Good question, for sure. When we are working on a brand new building commissioning project, we often are either on the temporary network or whatever network is online once the building automation system is turned on. And sometimes that's a temporary network being provided by the general contractor or the BAS contractor, MEP contractor. Sometimes, and then it runs through the commissioning, and then at substantial turnover, it goes from control of the network and it gets merged into the client network. So most of the time we're being installed, we like to be installed before everything's online. If we have good visibility to the project, our box is already plugged into a switch. It might be dark, but it's sitting there. And when the network comes alive, our device flashes up and we're able to discover systems as they come online. So a lot of times we have groups of systems, floor 6 is ready to go and they're still installing, Windows and some other floor sometimes. So we are able to kind of track with the progress. We join the commissioning meetings a lot of times so that we're present and we know the schedule and what groups of systems are being tested at what time. Some projects, of course, come online all at once. Other very large ones might take several months to kind of work their way through commissioning if they're being commissioned and even occupied sometimes in phases. Like I can think of a couple of smart hospitals we've done where, entire portions of the building are occupied and they're still pretty much finishing up on the rest of it. So yeah, I would say the comms get handled. Worst case, we use a cell modem, but usually the BAS network, of course, has to be online and live. The switches, the routing on that system need to be there. So hopefully that answered your question there, Keith. For that last case study with 20, we already talked about that. Let's see, any other devices required beside K-Link and KCOM if we have existing Kaizen, BACnet, and BMS already installed? No, that is the only device or devices. And if you have an existing Kaizen BMS, or if you have Kaizen already, then we already have the data from the read portion. We pretty much just need to add KCOM to be able to do the two-way interactivity with the BAS. So we wouldn't need to necessarily put a K-Link in place if you already have the BACnet communication coming to Kaizen. If you don't have that, or we want to update that, maybe it's a copper cube and we want to kind of build that back up, we could deploy that in parallel for a while and then phase out the other system you're using for collection. Another question here from Ryan. For ASO, can you implement a cloud-based guideline 36 control sequence for older VAV boxes that have configurable only, not programmable controllers? It's a good question, Ryan. I'm going to have to take that one offline. I would say if we're able to write to an output, as in, I would expect you could be, because there's got to be something that's able to write to that from the other controls. So it's not pneumatic, it's DDC. However, it's not configurable, as in not programmable. I would expect so, but I would have to put a pin in that one and check for you offline, which I will do, Ryan, and I'll email you. Good question, though. We don't come across tons of those, but I would suspect that we would be able to. Especially because for ASO, if what you're asking about is VAV boxes, for ASO, usually we're reading from the VAV. So so let me rephrase my answer. For ASO, we're optimizing the primary equipment, and we'd be using the output data reading from the VAV controller, not writing to it. So I would suspect that we would have the value, like the damper position, for instance. That's usually what we would use for the demand calc So we would probably still be able to read that. And then we would do the optimization using ASO down at the primary equipment. So I think so, but I'll take that offline anyhow and find out for you, Ryan. I think that was the end of the questions on the text. If there is others, I'm happy to answer those. Otherwise, again, feel free to reach out. My email address, kaylarose@coppertreeanalytics.com, and we can definitely catch up offline. If there's no other questions, I'll let everyone go. Appreciate everyone's attention today. Thank you so much.
Thanks, Keith. Great session. Cheers.
All right, cheers.